Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson we'll be looking at the printf function. We won't see everything about the printf function in this lesson, just enough to be getting on with and to kind of get you started on the world of C programming. The printf function is our mechanism for getting information out to the screen. So talking back to the user, you can consider it, because remember that when you write these programs, they normally have an end user in mind, so somebody that you're going to give this program to, and you need to have some way to actually send them messages and to ask them to do things and so on, or to display information to them. So the printf function is the way that you're going to do that. We're going to continue using this program that we've seen in previous videos, which is the little hello world program, but we're going to make some further modifications to it. So the important line here is the printf line, which I've just highlighted for you there. Now, firstly, to remember, and I mentioned this before, the top line here, #include stdio.h, that is the library from which the printf function comes. So somebody else has written the printf function for us. They've done all that hard work for us of getting the information onto the screen, and all we have to do is know how to use it. And as I said, that stdio, that stands for standard input output. In this case, our standard output is to the screen, and that's where the printf goes. So firstly to mention, and this goes for all of C, but it's the first time we've mentioned it here, is that C is case sensitive, which means that a capital P and a small p are considered completely different things to the C programming language. So for that reason, what I'm going to do is I'm going to deliberately make a mistake here. I'm going to put it as a capital P. That's one of the mistakes that people regularly make. And I'm going to compile the program. And we can see that we've got an error. It hasn't worked. It hasn't compiled properly. And here's where the error is. And if we click on it, you can see that it also highlights that particular line in green up here. And it says undefined reference to, and it says printf. Now the problem is that if you're just looking at that line and you haven't realized that you put in a capital P there, that seems to suggest that it doesn't recognize the printf function, and you think, well, what sort of compiler is it that it doesn't recognize the printf function? But the real problem is that it's actually pointing out to you that it's this particular spelling that it doesn't understand. Of course, it doesn't realize that it's an incorrect spelling. All it knows is, I've never heard of this thing before. So it's important to realize that the computers and compilers and so on, things like that, they see something with a capital P like that, they see that as a completely different spelling, a completely different word, and they don't recognize what it is. So important to spot those sort of errors when you see them. So a small p, and that goes the same, again, we couldn't put a capital M for main there, it has to be a small m. Same with return or any of these lines here. So the printf, and the printf puts information out to the screen. In this particular case, it prints out the statement hello world, and we see hello world come up on the screen there. And also what it does is it hops onto a new line for us here, and that's what this little thing here does. This is known as an escape sequence. And there are a number of these escape sequences that you can use, and indeed in some of the exercises I'm going to be getting you to investigate what some of the different escape sequences are. I'm going to show you one other one here, which is the \t. Okay, and let's see if we can figure out what it does. And what you'll notice here is that there's now a considerable gap between hello and world, much more so than was actually written in the program. In fact, I can put that directly up against that, and if we compile and run it, we can see that that gap is still there. If I put a second one in, so a second /t, we can see that there's now a double gap. So you've probably figured it out, but maybe not. The /t stands for a tab. So it's a special escape sequence that says, I want you to put a tab sequence in there to tab out the information on the screen. And this can be very useful if you want to format your information nicely. What happens if I put a /n in here in the middle of the two words? Well, I mentioned a minute ago that that's a new line. And so if we can see that hello is on top and world is on the bottom, so therefore it has gone on to a new line. And again, just as before, I can put in a second one of those. Sorry, hit the wrong button. So just save. In many cases, you don't have to say. Once you go to compile and run, it saves it anyway. You can see it's now put it a further line down. So each one of these you put in, it puts it a further line down. Now there are a number of these escape sequences, and in the exercises that I'll be getting you to investigate what some of those are for. So we'll we'll leave that for the moment as regards the escape sequences. Now, one of the other things that that the printf is quite good for doing is to print out information that we perhaps don't know when we're writing the program. In other words, it could be the result of a calculation that the program is going to do, and we don't know the result while we're writing the program. We only know it when it's executing, and the printf has to deal with that. So in doing this, what I'm going to do is I'm going to show you some things that you haven't seen yet, and I won't really be explaining properly until later lessons, but just bear with me on that. This is really to just show you the what the printf function does. So let's show you a mistake firstly. If I say 2 and my plus sign, if I could find it on this particular keyboard, there we are. 2 plus 2 equals, and I've written nothing there, right? And we can see it just says 2 plus 2 equals, and it says nothing. Now, I can put in the number 4 there, but this basically means that I'm doing the calculation for the computer. And that says 2 plus 2 equals 4, and that's fine. But what if I said 2 plus 2 equals 5? Will it have an issue with that? And it doesn't. It says 2 plus 2 equals 5. So what we find is that this section in here between the quotes, that's literally just text, and we can write whatever we want. It can be erroneous, or it can have all sorts of issues with it. We can say things that aren't true in there. It's just text. I could say 2 plus 2 equals Sean, and the compiler is not going to have an issue with that because this section in here is just text. Okay, so that's the first thing to show. Now, we have a system, and what I'm going to do here is I'm going to make some things called variables, and I won't be explaining these until a later lesson, but very shortly I'll be explaining them. So I'm just going to put them in for the moment, and you'll probably make a little bit of sense of what I'm doing here. I'll put in another one called Z. And I'm going to give these values. I'm going to say X is 2. I'm going to say Y is 2. And I'm going to say, I won't say what Z is for the minute, okay? Now, what I can do is the following. I can say X plus Y equals Z. And let's see if it adds those two things together. And it doesn't. It says literally X plus Y equals Z. And this again is just going back to what I said a moment ago. That's just text. So how do I get it to take the values that are here? Okay, and remember, in much later programs, we'll be able to actually get the user to decide what values they want there. So we definitely wouldn't know in advance what those numbers would be. So how do we deal with that situation? Well, what we do is we use things called convert. They're given numerous names. One is conversion characters. The other is format specifier. So I'm going to say %d plus %d equals %d. Okay. Now, the D stands for a decimal number, which is effectively your integer number. And the percentage sign is what tells us that it's one of these format specifiers. And effectively what this does is when the printf function comes across this terminology, it says, there's a number somewhere that I have to take in and put in its place here. I don't actually say this out. So I'm sure you've seen on many different comedy shows where somebody has been reading from an auto cue or something like that, and they've said, hello, my name is insert name here, and they actually read out exactly what's written there, as opposed to realizing that the insert name here means say your own name as you go. It's very similar here. You don't actually write the %d out on the screen. You go and you get a particular variable or number that it's looking for, and we must place them here outside of these quotes. And we must put them in the order that they appear there. So for instance, whatever we want to go in the first one, so whatever we want to go in here, that must appear here in the first case. So that's going to be our X here. We'll put in another comma to put our Y, so that's going to be the next one, and we'll put another comma to put our Z. And again, I'm going to show you what happens here, but you can expect that there is a mistake in what I've just done here. So. And we see the particular mistake in this case is that 2 plus 2 equals 0. And we know that that's definitely incorrect. So what we've managed to do is we've managed to get the 2 and the 2 in there. Okay. And indeed, if I was to change the x to a 3 here, without changing my printf function, if I run it again, we see that 3 plus 2 now equals 0. So I've managed to get the 3 to go in there, but I haven't done the calculation properly. And the reason for that is that we've said all that's happening is this one is being replaced by the x value, which is 3. This one is being replaced by the y value, which is 2. This one is being replaced by the z value, which has not been calculated. Okay, so you can see here where I have the z, we haven't said what z is equal to, and therefore it's, in this case it's defaulted to 0, but actually you're not guaranteed that it'll default to 0. It could default to any sort of random number depending on what happened to be in that location in memory before we ran the program. So to do this properly, I'm going to have to say x plus y. Okay, and we'll run that. And now we have 3 plus 2 equals 5. So it's done the calculation for us. Now it's calculated the value of z and it's put that in there. Okay. So it's important that you include all of these numbers here. If I was to accidentally leave one of them out, so I've 3% d's here, but only two pieces of information. Watch what happens in this case. We now have 3 plus 5, and the reason is we've taken out the y, so the z has moved forward one place and it's got put into the second position. It's added the two together, and luckily it's come out as an 8, but that's probably just an accident more than anything else, because the reality is that there's nothing to put in the next particular section. Okay, so I don't want you to jump to the conclusion that it actually did that calculation correctly, because it actually didn't. It doesn't know what's there in the next particular position. It just happens to be pulling whatever number is there from memory in the previous case. Okay, and what we'll do is we'll just see if I put that to a 6, and we'll see what. Now it may still do this, it may still be pulling, yeah, 3 plus 9 and is now equal to 8. So you can see that it's doing it incorrectly. So you can call it lucky or unlucky. In the last case, it happened to get the number right. That's interesting to see, because that can sometimes happen. You can write a program and you think it's working, but actually you've just accidentally got it. It's just accidentally popped up with an answer that looks correct. So be very wary of that when you're writing your programs. Make sure when you're testing your programs that you don't just test it with one set of values. Change the values around just to make sure that there isn't something unusual happening. Okay, so that's one of the important things about the printf function, with how we can put extra information into the thing. Okay, so just to do a quick recap on what we learned in this lesson. Firstly, the printf function, in order for the printf function to work, like anything else, it's case sensitive, so you must make sure that you spell it with all lowercase in the particular case, and it comes from this library here, so it's expecting to see that small or lowercase printf, or otherwise it won't work. The second thing we saw was that we have special characters that we can put in there. There are these ones which are called escape sequences, which can do particular formatting and so on. And there's a few more of those that you're going to have to learn. There are these ones here which are called either conversion characters or format specifiers, and you can understand why they're given those names. Format specifier specifies that I'm to take this number here and I'm to format it as an integer. Okay. And they're sometimes also called conversion characters. In other words, they convert it into a number. Okay, so just be aware of those. And as I said, there's a whole list of each of those sets of ones. And in the exercises, I'll be getting you to test out different types of ones. And some we won't be seeing until later in the course, because they're different types of variables and so on. Okay, and lastly, just be wary that when you're doing this sort of things that you know, what's in here is simply just text. So you can write this whatever way you want, but you must have the calculations done properly for it to come out as the correct answer. We've seen previously that we can quite easily print out the wrong answer for a question. So it's very much dependent on you writing the particular program properly. So that's just a brief introduction to the printf function. You'll be using it a lot throughout the course, and you'll be learning more as you go about how to use it. It's a very powerful function. Okay.